Okay, let's dive in. You just look around today, and data is, well, it's everywhere.
It really is, not just the usual stuff either.
Exactly. Not just text and numbers. We're talking images, audio, video, streams from, I don't know, countless sensors.
It's immense and fast
Yeah.
and incredibly varied.
And honestly, making sense of all that, turning that raw information into something actually useful, that's because, well, it's non-negotiable for pretty much any organization wanting to succeed today.
Right. Using data to guide your decisions. The sources we looked at make it crystal clear. That's not just a nice to have anymore.
No competitive edge, it's fundamental, just
Yeah.
keeping up.
Yeah, absolutely fundamental.
But you can't just, snap your fingers and suddenly get brilliant insights from terabytes of raw stuff,
Definitely not. It takes specialized skills.
which is why there's this whole ecosystem, right?
Yeah.
These roles dedicated to wrangling data, managing it, analyzing it, applying it. So our mission for this deep dive is to break down 5 key players that jumped out from the sources: the data analyst, data engineer, data scientist, the database administrator, and the business analyst.
A crucial lineup.
We're going to try and figure out exactly what they do, how they're different, and maybe the most important part, how they actually work together, to make data genuinely useful.
That's right. And if you connect this to the bigger picture, the sources really hammered home this fundamental shift.
From gut feelings.
Exactly. We've moved from a business world often running on intuition, maybe gut feelings, to one that has to be rooted in evidence.
Because the data's there now?
It is. The digital era hasn't just produced more data, it's really cemented data as a strategic asset, central to understanding markets, keeping customers happy.
I'm just staying competitive, frankly.
Just staying competitive, yeah. The ability to collect it, process it, analyze these large data sets, it's not optional anymore. It's core to almost every modern business.
And that brings us right into that big data challenge the sources talk about.
Yes. The 3 Vs.
The sheer volume, the incredible velocity, and the wild variety. There's just way too much happening way too quickly for any single person to handle every single aspect effectively.
Impossible.
Which is precisely why specialization became necessary, isn't it? You need different experts tackling different parts of the puzzle.
You do. And what the sources really emphasized for me was the emergence of the data team itself as a distinct unit.
Not just part of IT anymore.
Yeah.
Or finance.
Exactly, not just tucked away.
Yeah.
There's this growing recognition that data itself is, kind of a product or a service. It needs dedicated teams.
Okay.
And a really key takeaway from the material was that the effectiveness of all this data stuff, it relies heavily on how that team is structured.
How the roles work together.
Yes, how they collaborate. It's not just about throwing the latest technology at the problem.
Right.
The big challenges now seem to be about teamwork, about collaboration, making sure those data insights can actually be understood and, crucially, used across the organization.
So it's about a cohesive structure.
A planned, cohesive team structure and clear ways for these specialists to interact effectively.
Okay, that makes total sense.
Yeah.
It's not just having the players, but how they play together. Let's unpack the individual roles then.
Let's do it.
Starting with one many people think of first when they hear data, the data analyst.
Okay.
Think of them as maybe the detectives, uncovering insights from the present or the past.
Yeah, that fits.
Their core job, based on the sources, seems to be collecting, organizing, interpreting, and visualizing data.
To find those meaningful patterns, those trends.
Right. To help people make informed decisions based on what's happening now, they really focus on understanding current and historical data, kind of optimizing what the business is already doing.
So what does that look like day to day, according to what we read?
Good question. What did the sources detail?
Well, a variety of key responsibilities. A really foundational one is data cleaning and preparation.
The unglamorous but essential part.
Absolutely essential. This meticulous work of filtering, dealing with missing values, making sure everything's accurate, reliable.
They might scrutinize reports, looking for errors.
Exactly, catching errors before they cause problems. They also handle data collection, pulling data from databases, APIs.
Those ways different software talk to each other.
Right, and they even help maintain some of those databases sometimes.
Okay.
Then a big part is the analysis itself, applying statistical techniques to find patterns, relationships, trends.
And making it understandable.
That's where data visualization comes in, creating charts, graphs, those interactive dashboards so stakeholders can easily see what the data is saying.
Makes sense.
They're also responsible for reporting and communication, turning findings into reports for decision makers, sometimes even influencing company policy.
The sources mention automated reporting too.
Yeah, developing automated reporting processes. They look for trends and opportunities, analyze things like customer data to figure out how to improve the customer experience.
And they get involved in some basic database management, too.
Yes, some basic tasks to keep data accessible and secure. It's a broad remit.
Wow, that is a busy plate. And they
Yeah.
need a specific toolkit for all that, right? What skills and tools did the sources point to?
Absolutely. Essential skills include the obvious ones: data cleaning, data analysis, statistical analysis, and being really good at creating dashboards and reports.
Programming languages.
Python, R, and SQL come up a lot. SQL structured query language specifically for, asking questions of databases, getting structured data out.
And for making it visual.
Tools like Tableau and Power BI seem pretty standard in the industry.
Okay.
And, don't overlook just really strong spreadsheet skills. Advanced Excel proficiency is still crucial for a lot of initial analysis and modeling.
Right, good old Excel.
Uh,
But here's where it got really interesting for me. The sources specifically mentioned the scope expanding.
yes, into machine learning concepts.
Exactly.
This was a key insight, I thought. It really shows how the role is evolving.
How so?
Well, seeing machine learning listed among top skills and examples like analyzing traffic mortality, using techniques like multivariate linear regression.
Which is a statistical model for predicting outcomes based on multiple factors.
Right. Or k-means clustering, a method for grouping data points. It shows they're moving beyond just describing what happened or diagnosing why.
They're getting into prediction.
Increasingly, yes. Getting involved in predictive analytics, trying to figure out what will happen.
So that definitely blurs the lines with data scientists.
It really does. It means data analysts need a pretty solid grasp now of statistical modeling and ML fundamentals.
The sources even mention things like assessing medical treatments using R and regression, and complexities like Simpson's paradox.
Yeah, where trends look different depending on how you group the data. It shows the depth of statistical thinking that's becoming necessary.
Let's make that concrete. Some specific project examples we found in the sources.
Okay.
Analyzing unicorn companies using SQL to spot investment trends. Digging into sales data to understand product performance.
Standard analyst work, yeah.
Doing exploratory analysis and visualization on world population data. Then those more advanced examples, assessing medical treatments, and that really interesting project on reducing traffic mortality using ML models.
Those really show the practical application of that broadening skill set.
Okay, moving on. Let's talk about the data engineer.
All right. The builders.
Exactly. If the analyst is figuring out what happened, the data engineer is building the foundation, the plumbing that makes any analysis possible at all. Their core purpose, as defined in the sources, is developing, building, maintaining the data pipelines and the underlying infrastructure.
They take that messy, raw data
and transform it into something useful,
Yeah.
accessible for everyone else. They're heavy on the back end, making sure data is optimized, available when and where it's needed.
And what's fascinating here, a really important takeaway from the sources, is that they're not just doing IT work. They're the critical enablers.
Enablers for what?
For advanced analytics, for AI, they're building the highways, the processing plants for data.
Oh.
Without the well-designed, clean, accessible data they provide, the work of data scientists, even advanced data analysts, it would be severely hampered.
Slow down, or just
Just
impossible.
difficult.
Or, yeah, sometimes just plain impossible. If there's a bottleneck in how they move and prepare data, it cripples the organization's ability to do sophisticated analysis or scale up machine learning.
Got it. So what are their key responsibilities, according to the sources?
Well, things like data architecture design and management. That means designing, building, maintaining the whole structure of where data lives and how it flows.
Choosing the right tech, writing code.
Choosing technologies, writing code, setting up storage solutions. They also handle data collection and storage from incredibly diverse sources, including unstructured data.
Data that doesn't fit neatly into rows and columns.
Exactly. And they often act as the first line of data cleaning, spotting corrupt data early.
Okay.
Building ETL pipelines is core. ETL being extract, transform, load. Moving data, changing it, loading it somewhere useful like a warehouse.
And automation must be huge for
Yeah.
them. Huge. They write code, scripts, to automate repetitive processes, using tools like Apache Airflow, for example, to schedule and run data cleaning scripts automatically. Saves tons of time, reduces errors.
Makes sense.
They also have significant collaboration with data scientists, working together on early research, implementing new tech, helping with feature selection or engineering.
Which is choosing and preparing the right data for a model.
Precisely. They also ensure data quality and consistency across all those different sources. And sometimes, the sources noted, they might even get involved in model creation themselves.
Really?
Yeah, especially with huge data sets using big data tools like Hadoop or Spark, or even developing predictive models.
Okay, so they are definitely deep in the technical weeds.
Yeah.
Building the engine room. What specific skills and tools did the sources list for them?
Right, robust technical skills needed here. Strong programming is essential. Python, Java, Scala, and of course, SQL.
Big data tools.
Expertise in distributed systems, things that run across multiple computers. And yes, big data tools like Hadoop, Spark for processing massive data sets, Kafka for real-time streams, MongoDB for unstructured data,
What about storing the prepared data?
experience with data warehousing and ETL tools. Things like Amazon Redshift, Hivo Data, Talend.
Cloud platforms.
Absolutely essential. AWS, Azure, GCP. Sonar infrastructure is cloud-based now.
And automation tools.
Tools like Apache Airflow, Jenkins for automating builds, Git for code version control, Docker for packaging applications. Those are crucial.
Anything
A
else?
foundational understanding of machine learning concepts helps, and critically, a deep understanding of data architecture and pipelining, how data should flow and be structured.
Let's look at some concrete examples from the sources that illustrate their work.
Good idea.
Establishing data pipelines for smart IoT infrastructure. Yeah. Smart sensors generating tons of data.
Right.
Developing pipelines for aviation data analysis.
Right.
Building real-time financial market data pipelines. Integrating APIs. Using Kafka for those constant streams.
Complex stuff.
Implementing ETL for retail analytics using tools like Apache Beam or AWS Data Pipeline, warehousing in Snowflake or Azure Synapse, setting up log analytics projects, collecting logs, storing with Elasticsearch, visualizing with Kibana,
Yeah, that's a common one.
extracting and cleaning Yelp data using Python Pandas, storing in Azure Blob Storage, or designing full ETL pipelines using suites of cloud tools like AWS Glue, Spark on EMR, S3, Redshift, orchestrating with step functions in Lambda.
Those examples really show how foundational they are. They build the infrastructure that makes everything else possible.
All right, so engineers build the system, analysts find insights in the past, present. That brings us to the data scientist.
The future gazers, perhaps?
Yeah, maybe. According to the sources, they're focused on predicting the future and driving innovation.
Right. Analyzing complex data using advanced statistics, machine learning, building predictive models.
And coming up with business recommendations, the sources describe their focus as creating a futuristic display of data.
They often function as strategic partners to the business, catalysts for innovation, always looking ahead.
So they're dealing with the really complex, messy data.
Typically, yes, often unstructured data sets. Their sophisticated analysis helps organizations make those forward-looking decisions, improve future processes, design new products, fine-tune marketing.
And they're good at translating findings into recommendations, more so than other roles.
Often, yes. They usually have a higher proficiency there. It's not just handing over insights, it's translating complex, sometimes abstract findings into concrete, actionable guidance.
Influencing product roadmaps, market positioning.
Exactly. How the company positions itself, how they plan to engage with customers down the line, it's quite strategic.
So what are their key responsibilities?
Things like data identification and collection, figuring out what data is even useful for a complex problem, then gathering it from surveys, APIs, maybe web scraping.
Automatically pulling data from websites.
Right. They also handle data cleaning and structuring, transforming raw, messy data into a format ML algorithms can actually use.
And the core is model development.
A central part, yes. Algorithm and model development, creating, validating, testing, continuously updating algorithms for machine learning, for classification, prediction.
Using techniques like supervised learning, unsupervised learning, neural networks.
All of the above. Supervised, unsupervised neural networks, various kinds of regression analysis. It's a deep toolkit.
Visualization too.
Yes, like analysts, they use data visualization, but often to present findings from their complex models in a way that makes sense. And providing business recommendations based on that analysis is key.
Some specialize in R&D.
Yeah, the sources noted that. Some focus heavily on research and development, building entirely new systems, novel ML algorithms, enhancing existing functionalities like web browsers.
And they get involved in strategic planning.
often involved in the long-term strategic planning for a company's data analytics direction.
So they need a seriously deep blend of skills: stats, programming, business sense. What did the sources highlight?
Strong analytical skills, obviously. Researching, examining, interpreting complex problems. Robust computer skills coding, working with large data sets, refining algorithms.
Languages.
Python and R are standard. SQL's still essential for getting data. Others like SAS, Java, Perl pop up, depending on the context.
And the method.
A comprehensive understanding of statistical methods, advanced statistics, machine learning, deep learning principles, data mining too, discovering patterns in large data sets.
Big data tools.
Often use Hadoop, Apache Spark, especially when training models on massive data.
And other skills.
Crucially, strong problem-solving and logical thinking skills for those complex, often ill-defined problems, and equally strong communication skills to explain very technical findings to non-technical leaders.
Let's hear some specific real-world examples from the sources. What does a data scientist actually tackle?
Okay. Customer segmentation for retailers using clustering algorithms to group customers for targeted marketing.
Makes sense.
Sentiment analysis for social media using natural language processing, NLP techniques.
Like bag of words or n-grams.
No.
Ways of representing text data.
Exactly. To understand how people feel about a brand online. Image recognition for security using computer vision and ML.
Monitoring models after deployment.
Yes, like monitoring a financial fraud detection model using Python to ensure it's still working correctly, or developing predictive models for customer churn rate prediction.
Figuring out who might leave so the company can try to keep them.
Precisely. Their work is highly strategic, aimed squarely at driving future business outcomes.
Next up, the database administrator, or DBA.
Ah, the guardians.
Good word for them. If the engineer builds the highways, the DBA keeps the traffic flowing smoothly, securely, reliably. Caretakers of the data itself. Their core purpose, according to the sources, is the development, maintenance, management of the systems that actually store the databases, ensuring efficiency, security, reliability. Always.
And the sources made it really clear they are the fundamental guarantor of data trustworthiness and organizational resilience.
Why so fundamental?
Well, their role in ensuring data integrity, accuracy, consistency, and security, that's the absolute foundation for any reliable data work.
Right. Garbage in, garbage out.
Exactly. Data quality isn't just nice for analysis, it's critical for making any valid, trustworthy decisions. Their work underpins everything. Analysts, scientists, everyone else does.
If the data isn't accurate or available?
The sophisticated analysis, the modeling, it's all potentially built on quicksand.
Okay. So what are their key responsibilities day to day?
Things like database installation and configuration, getting the software set up, configuring hardware, OS, setting up admin accounts, managing memory limits.
And security is massive for them.
Absolutely massive. User access and security management. Controlling who gets in, how they authenticate, maybe implementing multi-factor authentication, MFA, SSL for secure connections.
Assigning privileges.
Assigning privileges using role-based access control, RBAC, giving users only the permissions they need. Implementing encryption, managing patches to fix vulnerabilities, setting up audit trails with DAM tools to track who did what.
Wow, okay. What else?
Setting up backup and recovery procedures, hugely important. Planning strategies against data loss breaches, hardware failures, disasters.
Different types of backups?
Managing different types, full, differential, incremental, and being responsible for recovery if things go wrong.
Performance monitoring?
Constantly. Performance monitoring and optimization, identifying bottlenecks, gathering metrics, using techniques like partitioning to speed things up, ensuring data integrity through constraints and validation rules.
Troubleshooting?
Troubleshooting and resolving issues, performance problems, connectivity errors, data corruption, security breaches, and they collaborate closely with dev teams, IT ops, cybersecurity, and the analysts and scientists using the data.
Deep technical specialists focused on stability and security. What specific skills and tools did the sources mention for DBAs?
Deep expertise in specific database management systems, DBMSs, Oracle, SQL Server, MySQL, PostgreSQL, maybe NoSQL like MongoDB.
SQL knowledge.
Non-negotiable. Deep SQL knowledge. Proficiency in scripting languages for automation, too.
And core skills.
Core skills are security management, performance tuning, and just really strong problem solving to diagnose and fix issues quickly.
Can you give some concrete examples of tasks they perform?
Sure. Real-world tasks. Configuring user access with MFA and setting up granular RBAC rules. Implementing a comprehensive backup strategy.
Tailored to the company's need.
Exactly. Troubleshooting a database bottleneck by analyzing metrics and optimizing slow queries. Ensuring data integrity by enforcing constraints. Or managing database migrations, planning and executing moves between servers, platforms, or clouds.
Foundational work. Guaranteeing the infrastructure is robust, secure, reliable.
Which allows everyone else to do their jobs effectively. Absolutely foundational.
Finally, number 5, the business analyst.
The bridge builders.
Yes, the crucial human layer, bridging that technical data world with the real-world business needs. Their core purpose, according to the sources, evaluating data, identifying trends, recommending solutions to improve business processes. They're the key link between business stakeholders
The people who know what the company needs.
and the technical teams building the solutions. The sources called them a value realizer, a strategic integrator.
And their role is just vital for ensuring all that technical data work actually translates into tangible business value.
How so?
They're the ones who can take complex technical findings and translate them into language non-technical leaders understand. And vice versa, take abstract business problems and turn them into concrete requirements for the tech teams.
The example showed that connection to value.
Definitely. Project examples like market basket analysis, price optimization, sales data analysis, they show how BA work directly leads to measurable business improvements, revenue generation.
So they're not just passive recipients.
No, they actively work to ensure insights get translated into action that benefits the bottom line, making sure the technical solutions actually solve real business problems and deliver value.
Okay, what are their key responsibilities?
Requirements gathering is a big one. Conducting interviews, running workshops, thoroughly documenting what the business actually needs.
They do data analysis too.
Yes, they perform data analysis themselves to evaluate performance, find inefficiencies, spot opportunities. Process documentation is essential generating user stories.
Describing features from an end user perspective.
Right. Use cases, workflow diagrams, system requirements, business cases justifying projects. They facilitate user acceptance testing, UAT,
Making sure it works for the users.
validating that the solution meets requirements and works for the people who will use it. They often provide project management support, coordinating teams.
And communication is key.
Arguably their most critical skill, communication and translation, bridging that business tech jargon gap. And their focus is always process optimization, using data to recommend changes for efficiency or effectiveness.
So they need a blend of business-savvy analytical skills, strong communication. What skills and tools did the sources list for a good BA?
Strong analytical skills, definitely. Understanding data, identifying root causes, evaluating solutions. They use data analysis tools, Excel, SQL for queries, BI tools like Tableau, Power BI.
Right.
Sources said programming in Python or R can be optional but increasingly beneficial. Communication skills, paramount. Clear explanations, tailoring the message. Documentation abilities are key.
Project management knowledge.
Familiarity with methodologies like Agile or Scrum is helpful. They use diagramming tools like Visio or Lucidchart to map processes, and project management tools like Jira, Confluence, Asana to track things.
And to wrap up the examples for the BA role, what kind of projects?
Specific projects. Market basket analysis for optimizing product placement or cross-selling. Customer review sentiment analysis using NLP tools.
Price optimization.
Price optimization strategies based on data. Sales data analysis often overlapping with the data analyst, highlighting that collaboration.
Overlapping with data scientists too.
Yes, analyzing data for customer turn rate prediction, again showing collaboration. Identifying suspicious activities for fraud detection, overlap with DS and DA there too. And social media reputation monitoring.
They ensure the data work supports business outcomes. Measurably.
That's the goal, ensuring it improves the business.
So you can clearly see how each role is distinct, needing specialized expertise. But how do they actually function together in a real organization?
Right, because the sources really emphasize that the modern data team is inherently cross-functional, interdependent.
Across the whole data lifecycle, collection to insights.
Exactly. Collection, storage, processing, analysis, insights. This specialization isn't about silos. It demands a highly collaborative, strategically structured team.
How does that flow typically work based on the sources?
Well, what's fascinating is seeing that flow. It usually starts with raw data being ingested, structured by the data engineers. They build the pipelines, prepare it, put it in warehouses or data lakes.
With the DBAs guarding the gates.
The DBAs are the essential guardians, ensuring security, integrity, performance of those repositories. Foundational.
Then the analysts and scientists access it.
Right. This prepared, reliable data is accessed by data analysts focusing on current historical insights. What happened? Why? And data scientists access it to build predictive models. What will happen? How can we optimize?
And the business analysts tie it all together.
The insights from both DAs and DSs are then consumed, interpreted, contextualized by the business analysts. They translate it into actionable recommendations for the business, gather requirements for new initiatives, asking, how can we improve things with data?
And that creates this natural feedback loop, doesn't it? New requirements from BAs might mean new pipelines for DEs or new access for DBAs.
Exactly. And that comparative overview from the sources summed it up nicely, right? The core question for each.
DA, what happened, why? DV, how to process data efficiently.
DS, what will happen, how to optimize. DBA, is data safe, consistent, available?
And BA, how to improve business with data.
Yeah. And the effectiveness of the whole system, the sources really stress this, it doesn't come from one role being brilliant alone.
It's the collaboration.
It's the collaboration, the seamless handoffs, that shared understanding. If one area is inefficient, DEs can't get data ready, DBAs can't keep things running, BAs can't translate findings, it impacts everyone downstream.
It's about the collective effort.
The collective synchronized effort of the team, that's where the magic happens.
So as we wrap up this deep dive, we've looked at 5 absolutely key roles: data analyst, data engineer, data scientist, database administrator, business analyst.
Each distinct, but indispensable.
Right. Each brings unique contributions. From the foundational architecture and security built by DBAs and DEs, to the insights from DAs, the predictive power from DSs, and that crucial strategic alignment from BAs.
Working together, they transform raw data into a powerful engine for growth and innovation.
And the sources really hammered home that the true power comes from that effective collaboration.
Seamless teamwork, understanding dependencies, a unified vision, absolutely key. Whether a company organizes centrally or spreads the team out, that knowledge sharing between specialists is essential.
Turning data into action quickly.
And making sure it all actually helps the business achieve its goals.
And it's a landscape that's constantly changing, isn't it? New tech, new tools, evolving business needs.
Which means continuous learning, adaptation for everyone in these fields, no matter the role. Absolutely.
You know, considering how complex things are getting, how reliant we are on data, one interesting thing to maybe ponder is, what are the biggest non-technical challenges organizations face in actually getting these specialized data roles to collaborate effectively day to day?
Beyond the org chart and the tools.
Yeah. To truly unlock data's full potential, it's something worth thinking about as you navigate this dynamic data world.